Welcome back to Science Explained, the channel where science finally makes sense. Today we re-diving into the fascinating world of mechanics, specifically the common forces that govern how objects move, stop, slide, or even float. Whether you're a student, a curious learner, or just someone who wants to understand physics in real life, this video is for you. Let's get started. Let's start with the basics. What exactly is a force? In physics, a force is simply a push or a pull acting on an object. It can change an object's motion, shape, or both. Mathematically, we express force as F equals ma, where F is the force and is mass and a is acceleration. Force is a vector quantity, meaning it has both magnitude and direction. Now that we understand what a force is, let's break down the most common forces you'll encounter in mechanics. 1. Gravitational force. This is the force of attraction between two masses. On Earth, gravity pulls everything toward the center of the planet. It's why apples fall and why we don't float into space. Formula Fg equals mg, where g is the acceleration due to gravity, approximately 9.8 meters per second squared. 2. Normal force. This is the support force exerted by a surface that's perpendicular to the object. When you place a book on a table, the table pushes upward. That's the normal force balancing gravity. 3. Frictional force. Friction resists motion. And there are two main types. Static friction, which keeps an object at rest, and kinetic friction, which resists motion when the object is moving. It depends on two things: the surface texture and the normal force. Formula: F friction equals μn, where μ is the coefficient of friction. 4. Tension force. This is the force that's transmitted through a string, rope, or cable when it's pulled tight by forces acting from opposite ends. Think of tug-of-war or an elevator rope. 5. Applied force. This is simply the force you exert on an object when you push or pull it directly. It's usually the force exerted by a person or machine on an object. 6. Air resistance or drag force. This is a type of frictional force that acts against motion through the air. It increases with speed and surface area. It's why skydivers eventually reach terminal velocity. 7. Spring force or elastic force. Hooke's law tells us that springs exert a restoring force when stretched or compressed. Fs equals negative kx, where k is the spring constant and x is the displacement from equilibrium. These are the primary forces you'll commonly encounter in mechanics. However, if you're interested in delving deeper into the world of physics, there's more. For instance, electromagnetic force, which encompasses magnetism or electric repulsion and attraction, is also a mechanical influence, particularly in systems of charged particles. We'll save that for another episode. So now you know the basic forces, but how do we analyze them? When multiple forces act on an object, we calculate the net force. Net force equals the sum of all vectors. To visualize these forces, we use something called a free body diagram, or FBD. An FBD is a representation of all the forces acting on an object. Each force is drawn as an arrow pointing in the direction it acts. Using this, we can determine the object's motion using Newton's laws. Now that you understand these concepts, let's see how they play out in real life. A car driving on a road. Several forces come into play. Friction between the tires and the road. The normal force from the road pushing up on the car, gravitational force pulling the car down, and the force from the engine pushing the car forward. A book resting on a shelf. The normal force from the shelf balances the weight or gravitational force acting on the book, keeping it at rest. A skydiver falling. Gravity pulls the skydiver down while air resistance pushes up. Initially, gravity dominates, causing the skydiver to accelerate. As they approach the ground, air resistance increases, eventually reaching a point where it balances the gravitational force, resulting in a constant velocity called terminal velocity, a box being pulled with a rope. Several forces act on the box: the applied force from the person pulling the rope, tension in the rope, frictional force opposing the motion, and gravity pulling the box down. Understanding these forces and how they interact is crucial in various fields. Engineers use this knowledge to design structures like bridges and machines that can withstand different forces. Astronauts rely on it to launch rockets and spacecraft and to maneuver them in space. Athletes, too, utilize their understanding of forces to enhance their performance. By knowing how to apply forces effectively, they can optimize their movements in sports such as running, jumping, and throwing, and that's a wrap. Now you know some of the most common forces in mechanics and how they work together to shape our physical world. If you found this helpful, please give us a like. Share it with your friends and consider subscribing for more Science Explained Simply. Got questions, comments, or want to suggest a topic for us to cover next? Drop them in the comment section below. At Science Explained, our mission is to make science more accessible and understandable for everyone. We believe that with the right guidance, anyone can grasp complex concepts and appreciate the wonders of the scientific world around us. Thanks for joining us today, and until next time, stay curious, stay brilliant. This has been Science Explained.